Okay. Hi, everyone. My name is Connie. I'm 16 and I'm going to start my senior year of high school at the downtown school. Today, I'm presenting on an intelligent mobile app to assist in healing a dancer's injury using artificial intelligence. Also, I am a little bit sick, so please don't mind if I mute to cough or something like that. Okay, the app DanceWell was created to help dancers quickly get free medical advice for the injuries. I've had multiple injuries, and scheduling doctor or physical therapy appointments were always difficult because of their lack of availability. Meant I'd have to wait weeks to get checked out or go at an inconvenient time. I remember one time I had a physical therapy appointment during the lunch break of my school because there were no other times available. I know waiting around isn't always an option because dancers want to continue dancing or might have a performance coming up, so DanceWell can provide immediate assistance right away when they need it. It's not meant to completely replace doctors, but in the time leading up to the appointment, dancers will have an idea of what their injury is, and they'll be given treatment advice and exercises to alleviate their pain. I also know healthcare can be incredibly expensive, and the doctors that treated me didn't accept my insurance, so my parents had to pay out of pocket. Not everyone can afford it, and with that in mind, DanceWell offers professional advice while being completely free. To use the app, a user selects the injured body part and responds to the 10 subsequent yes or no questions. They have the option to upload photos of the injury. The app then uses artificial intelligence to analyze a user's response, including swelling, discoloration, bruising, or more from the photo if submitted. By comparing it to a database of common dance injuries, the user would be given a diagnosis and treatment options, including advice and physical therapy videos and future prevention tips. Let's take a look at what the app looks like. So the first page of the app is the entry point for users where they can either sign up for a new account or log into an existing one. This page is designed to ensure that only registered users have access to the app's features, helping to maintain a personalized experience. New users can create an account, while returning users can easily log in to continue where they left off. This step is crucial for managing user data, tracking their progress, and storing their previous injury assessments and advice securely within the app. The homepage features two main buttons, Get Started and About Us. The About Us button takes the user to a page that explains who I am and the reason behind creating this app, which I already talked about. It provides a brief background on my experience and the inspiration for developing a tool specifically for dancers. The Get Started button, on the other hand, leads the user to a pre-assessment page. This page prepares the users by explaining what they can expect in the upcoming steps, such as the types of questions they'll answer and how the app will use their input to provide a diagnosis. This setup helps users feel informed and ready before they begin the assessment process. The image on the left is the About Us page, and the image on the right is the pre-assessment pages that I just talked about. Please note that I will change the email. I'm just not sure yet if I want to create a professional email account or use my personal email. The body page of the app prompts the user to select the body part that is injured from a visual and label diagram. This allows the app to tailor the following questions and analysis to that specific area. If the injured part isn't labeled or doesn't match any of the available options, the user can easily click the Other button. This option ensures that the app can still proceed with gathering relevant information, even if the injury is less common or located in an area that is not explicitly listed. This flexibility helps make sure that all potential injuries are covered. The assessment page presents the user with 10 yes or no questions specifically tailored to the body part they selected earlier. These questions are designed to gather detailed information about the injury, helping the AI make an accurate diagnosis. At the end of the assessment, the user has two options. They can either submit their answers directly for an immediate diagnosis or choose to upload a photo of the injured area for a more thorough analysis. This photo, combined with the answers to the questions, allows the app to provide a more precise diagnosis and relevant treatment recommendations. The results page displays the AI's assessment based on the user's input and any uploaded photos. This includes a possible diagnosis of the injury, offering an overview of what might be wrong. Additionally, the page provides general advice on how to manage the injury, as well as specific recommendations tailored for dancers. These dancer-specific tips are designed to help them continue their practice safely or recover in a way that aligns with their unique physical demands. This combination ensures that dancers receive both accurate medical advice and guidance that is relevant to their needs as dancers. Here are a few challenges I encountered while completing the project. The image picker in my program lets users upload photos of their injuries for AI diagnosis. However, issues like poor image quality and bad lighting could reduce the accuracy of the diagnosis because the AI will have trouble seeing the image clearly. To address this, I could implement image processing techniques to improve the quality and lighting of the photos. Additionally, I could provide the users with guidelines on how to take clear, well-lit photos. Another concern is user privacy, which I could handle by encrypting the uploaded images and ensuring they are securely stored and processed in line with privacy regulations. A crucial part of my program is the page where users answer 10 yes or no questions after selecting the body part that hurts. Potential issues include users misunderstanding the questions or giving inconsistent answers, which could impact the accuracy of the diagnosis. To address this, I can make sure that the questions are written in clear, simple language and include examples to clarify each one. Additionally, I can implement validation checks to ensure the answers are consistent. If any discrepancies are found, the system could prompt users to review their answers before submitting, leading to more reliable input for the AI diagnosis. Another key part of the program is the AI diagnosis system. One potential issue is that the AI might make inaccurate diagnoses, which could lead to incorrect treatment recommendations. To mitigate this, I could train the AI using a large and diverse set of medical images and case studies, helping it learn to recognize a wide range of injuries and conditions. Additionally, I could regularly update the training data with new examples and user feedback to continuously improve the AI's accuracy. Another approach to enhance reliability is involve having medical professionals review and validate the AI's diagnoses over time. Let's look at some snippets of important code and explain what they do in the app. So this screenshot shows a part of an application, the application, where a function named Gemini function calling is defined. This function is asynchronous, which means it allows the application to perform other tasks while it waits for a particular operation to complete, like getting a response from the server. In the code, there are two string variables, system prompt and user prompt. The system prompt instructs the app to act like a doctor specialized for dancers, giving an assessment and advice based on symptoms. The user prompt asks the user to provide 10 yes or no questions in a JSON format about a specific body part, which will be used to assess their health. The method start chat in the code is used to begin a chat or session with an AI model. This method takes a history that includes user prompt and system prompt to guide the conversation. The content.text parentheses user prompt and the content.model parentheses text part system prompt prepare and send this information to the AI model. When this code runs, it's during a part of my app where a user decides to start the assessment to diagnose their injury. The AI model, upon receiving these prompts, generates specific questions based on the user's input and provides a system response based on the setup logic in system prompt. This interaction is stored and processed further to give the user a detailed health assessment based on the provided answers and further medical advice like treatment options and prevention tips. The image upload and diagnosis feature lets users upload a photo of their injury. It uses neural networks to analyze the image and help diagnose the injury. This makes the diagnosis more accurate by combining the photo with answers from the user's questionnaire. This screenshot shows a part of an application where a function named getGalleryImage is defined. This function, like the last one, is also asynchronous. In the code, the picker.pickImage method is used to open the device's gallery, enabling the user to choose an image. This method specifies the source as the gallery sets the image quality to 80% to reduce the file size. The function uses the await keyword, which pauses the execution until the user selects an image or cancels the action. The setState function is used to update the application state after the image is picked. If an image is picked, it saves the image path in the _image variable and prints image picked to the console. If no image is selected, it prints no image picked instead. This code runs when the user wants to upload an image, typically for further analysis or display within the app. The app is then available for processing, such as being analyzed by the AI for diagnostic purposes. This screenshot shows part of the application where a function named Gemini function calling is defined. The function is also asynchronous. In the code, the model.startChat method is used to initiate a chat section with a generative AI model. The chat is initialized with a history that includes a response to previous questions and basic greeting messages like, "Hello, how can I help you?" This history helps the AI understand the context of the current session. Next, a message is prepared in the message variable, instructing the AI to act as a doctor for dancers, providing an assessment based on the symptoms. This message is then converted into content using content.text message, and the chat.sendMessage content method is called to send this message to the AI. The app waits for the AI to process the message and return a response. Finally, the setState function updates the app state with the AI response, storing it in the result variable. This result is then displayed to the user, providing them with medical advice based on their symptoms. This function runs when the app needs to communicate with the AI model to generate a diagnosis and advice for the user. Here are some experiments to make sure my app runs properly. So a potential issue in my program is the accuracy of the AI. It's crucial that the AI provides the correct questions for each body part, as an incorrect set of questions could lead to a wrong diagnosis for an answer. To test the AI's accuracy, I can run an experiment by selecting a specific body part and checking if the AI generates 10 relevant questions for that part. I'll repeat this for different body parts to ensure the AI consistently links the chosen part with appropriate questions. For example, in the image, when I selected the cervical spine or neck body part in the app, it correctly led me to a page with 10 questions specifically about the neck, confirming the AI's accuracy in this instance. Ensuring the AI's accuracy in diagnosing injuries is crucial for the safety and effectiveness of the app. To thoroughly test this, I plan to compare the AI's diagnostic results, which are based on user-submitted images and answers to the questions, with the assessments made by a qualified medical professional. This comparison will help determine how closely the AI's conclusions align with those of a human expert. By analyzing the similarities and differences between the AIs and professional diagnoses, I can identify areas where the AI excels and where it may need improvement. This process will involve reviewing multiple cases to ensure that the AI consistently provides safe and reliable advice across a wide range of injury types. Additionally, any discrepancies found will show me how the AI can be further refined. This rigorous testing is essential to ensure that the app not only offers quick and accessible advice, but also maintains a high standard of safety and reliability for its users. And then here are some limitations of my app. One limitation is that the app doesn't link an injury with a user's account. Every time a user gets diagnosed with an injury, it won't show up in their account history. To fix this, I would code it so the diagnosis gets saved in their history. Clicking on it would lead to the expanded details, such as a user's response to the questions, any uploaded images, treatment plans, prevention tips, and physical therapy videos. Another limitation is that a user can upload an image of their injury, but they can't take a photo in the app, which makes it slightly inconvenient. Although it's unlikely, if a user's camera app doesn't work, they won't be able to upload an image. To fix this, I would just add a feature for users to take photos in my app on top of the image picker feature to give users more options. And then now let's do a sample run of my app. So I'm gonna be using one of my previous injuries. Exactly 1 year ago, I injured my foot while jumping during a summer intensive. And for some reason, I thought I could push through the pain. So I kept dancing for 9 hours a day for the next 2 days, I think. And to no surprise, the injury got so bad, I had to pull out of the program, even though it was only halfway done because I just couldn't continue dancing. And the top of my foot was in pain for the next few months. Okay, so first, I need to select the body part, and the injury was, of course, on my foot. So after selecting that, I was asked to answer the 10 yes or no questions about my foot. The questions I said yes to are, do you have any pain in your foot? Does your foot hurt when you walk or run? Do you have swelling in your foot? And has your foot been injured recently? I did have a foot injury prior to this one, which was something about inflamed muscles, which is why I said yes. I said no to, is your foot red or discolored? Do you have any blisters or open sores on your foot? Does your foot feel numb or tingly? Do you have any weakness or loss of function in your foot? Do you have any other medical conditions that could be affecting your foot? And are you taking any medications that could be affecting your foot? I unfortunately don't have a photo of my injury, so I will just submit my answers without using the photo feature. Here, the AI gave me 3 possible diagnoses for my injury, which was a sprain, a strain, or a fracture. Even though the answer seems unclear, the AI is very accurate since these were all possibilities the doctor was considering. We still aren't sure exactly what the injury was, but we ruled out the possibility for a stress fracture after I got an MRI. We decided it was either a small sprain or strain, so the AI was very accurate in the case of my injury, especially because an AI cannot diagnose a stress fracture. That's something you have to go in person and get either an X-ray for or an MRI for that. In conclusion, DanceWell is an app created for dancers and utilizes AI to diagnose an injury by interpreting a user's response and analyzing images. Thank you for listening.